Data visualization and network visualization. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. Network virtualization enables network administrators to move virtual machines across different domains without reconfiguring the network.
There are many types of graphs and visualizations, and the choice of which one to use depends on the nature of the data being presented and the message that needs to be conveyed. Here are some of the most common types: line graph, bar chart, pie chart, scatter plots. Line graphs shows how a variable changes over time. Bar charts compare values across categories by using bars of different heights or lengths. The pie chart shows the proportion of different categories in a dataset as slices of a circle. The scatter plot shows the relationship between two variables by plotting them on a two-dimensional graph. More examples of types of graphs and visualization: histogram, box plot, heat map, tree map, network diagram, flowchart.
Network metrics are qualitative and quantitative ways to watch and decide network behavior. Network metrics measurements include network capacity, network utilization, throughput, one-way latency, round-time trip, packet loss, and packet duplication. Network analysis helps in deep understanding the structure of a relationship in social networks, the structure or process of change in natural phenomena, or even the analysis of biological systems of organisms. Network analytics gives more profound knowledge of how the network is performing and how an organization is utilizing the network.
In social network analysis, centrality refers to the degree to which an individual or group is connected to other within a network. Centrality can be measured in different ways, but typically it involves assessing the number of strength of connections that a person has within other in the network. The more central a person is in a network, the more important they are in terms of communication and information flow. On the other hand, clusters in social network refers to group of individuals who are more densely connected to each other than to other in the network. In other words, clusters are group of people who share common interest, experience, or social ties and who tend to interact with each other more frequently than with people outside of the cluster. Both centrality and cluster can be useful for understanding and structure and dynamics of social networks. For example, identify central individuals or group can help to explain patterns of influence, communication, and information flow within a network, while identifying clusters can help to identify subcommunities within a network and the potential for information or idea to spread within and between these groups.
Graph-based machine learning is a type of the machine learning that uses the graph or networks to represent data, such as a social network analysis, recommendation systems, and image segmentation. Data is represented as a graph where nodes in the graph represent the data point and edges represent the relationship between the data points. Graph-based machine learning techniques: graph neural network, graph clustering, graph embedding.
Algorithm X based on the algorithm X. Python is a library for the network visualization and algorithm simulation. It may be used in Jupyter Notebooks and Jupyter Lab as with or through an HTTP WebStock server. When picking an algorithm for the network visualization, bear the following considerations in mind. Those are the scalability, layout excellence, flexibility, interactivity, compatibility.
Data visualization, in turn, converting your data from a textual representation to a visual one. By doing this, you are able to see the relationships and the pattern that the person might find difficult to comprehend otherwise. Social network analysis imports a data into a graphical program with the aim of the understanding society and its structure. Analysis notes, which might be individuals or a group of individuals, understanding the social structure, and links show how these nodes are related to one another.
Visualizations have a significant impact on social network analysis by providing a powerful means of representing and understanding complex relationships between individuals or entities in a social network. They can facilitate pattern recognition, enable exploration and discovery, enhance communication, support decision making, and ultimately enable users to gain new insights and make more informed decisions.